Hello, today we are going to learn about Valence Bond Theory, which is short formed as VBT. VBT is a theory which gives us a clearer interpretation on how a molecule is formed by chemical bonding, especially covalent bonding and their molecular structures. Valence bond theory is actually based on the concept of atomic orbitals and their overlapping. We know that in an atom, the electrons are occupied in various atomic orbitals like s, p, d, and the f orbitals, right? According to valence bond theory, a chemical bond is formed by the overlapping of half-filled atomic orbitals of individual atoms. The overlapping of half-filled atomic orbitals will result in the pairing of electrons between these two atoms, and that will result in the formation of a chemical bond. But all kinds of overlapping between atomic orbitals cannot result in a chemical bond. There are certain conditions to be satisfied for the overlapping to result in a chemical bond formation. The first condition to be satisfied is that the two atomic orbitals which are undergoing overlapping should have same phase or same sign. We know that except s orbital, all the other orbitals, let it be p, d or f orbitals, all these orbitals have positive and negative lobes. In-phase overlapping means the overlapping between the lobes of similar sign, that is, positive lobes should overlap with another positive lobe, or a negative lobe should overlap with another negative lobe. Okay, so this is what it means by in-phase overlapping. Then the second condition to be satisfied is that the atomic orbitals which are undergoing overlapping should have same orientation in space. That is, if we are considering the case of a px orbital which is lying in the x direction or x axis, it can overlap only with another px orbital which is lying in the same x direction. It cannot overlap with a py or pz orbitals which lie in y or z axis. Okay. So these are the two conditions to be satisfied for the overlapping of atomic orbitals to result in a chemical bond formation. Now, based on the manner in which these atomic orbitals overlap, there are two types of covalent bonds. The first one is sigma bond and the other is pi bond. The sigma bond is formed when the two atomic orbitals are overlapping in head-to-head or end-to-end fashion. For example, if we are considering the case of overlapping between two s orbitals command overlapping, that will be always in head-to-head fashion. So it is a sigma bond. Then if we are considering the head-to-head overlapping of two p orbitals head-to-head fashion, then that will also result in a sigma bond. And another example is the head-to-head overlapping between an s orbital and a p orbital in head-to-head fashion. That can also result in a sigma bond formation. So sigma bonds is of three types. In head-to-head fashion, SS overlapping, then PP head-on overlapping and PS head-on overlapping. Then the next kind of covalent bond is pi bond. Pi bond is formed when the overlapping atomic orbitals are overlapping in sideways fashion. This can only happen in the case of p orbitals. If two p orbitals are coming and overlapping in side-to-side fashion, that will result in a pi bond. Now, talking about the strength of these bonds. The strength of a covalent bond is dependent on the extent of overlapping. If there is only very less amount of extent of overlapping, that will result in a weak bond. And if the extent of overlapping is maximum, that will cause a strong bond. The extent of overlapping is greater in the case of sigma bond since it is head-to-head overlapping. Therefore, sigma bond is always stronger bond than that of a pi bond. So these are the things that we have to keep in mind while we are talking about valence bond theory. How the covalent bond is formed? Covalent bond is formed by the overlapping of atomic orbitals, and that should be in phase and in same orientation, and based on the manner in which they overlap, there are two types of bonds. One is sigma bond and the other is pi bond. Based on the extent of overlapping, we can tell that the sigma bond is more stronger bond than that of pi bond. Thank you.